Hello and welcome. You all have heard, if you want your LLM to be more deterministic and factual, then choose a lower temperature. And if you want it to be more creative, then choose a higher temperature. And in this video, I want to explain mathematically why exactly this is the case. So let's jump right into it. To understand how temperature works, we need to first understand the softmax function and what it does. So you have to think about it like the LLM or the transformer model computes the logits. You can think of logits like raw probability scores the LLM outputs to predict the next token. And the softmax function scales the logits, so we have a probability distribution between 0 and 1 for all the possible tokens that the model can predict. And the formula looks like this, where we have the E function where z is the logit, so we apply the E function on the logit and we divide it by the temperature. And we normalize the result by dividing it through the sum of all logits which were applied to the exponential function. Normalization only basically just means that we turn the result into a score between 0 and 1. But let us first have a quick look at the exponential function. So there are a couple of things we need to keep in mind. The first thing is if you put 0 in the exponential function, you get a 1 as output. And negative numbers will approximate to 0. And for larger numbers, it grows exponentially, obviously. Okay, now let's go to a concrete example. Imagine we are trying to predict the next word for I'm going to the, and here with the temperature 1, I have calculated it. So let's say the LLM outputs the logits of 2, 1, minus 0.5, minus 2, minus 3. Then you can obviously see a larger logit applied to the exponential function will result in a larger function. We have seen it here. If you put in the 1, we will be here at 2.7, minus 0.5, we will be somewhere here, 0.6, and so on. Now here I have printed the calculations. If we sum up the exponential of the logits, we get 10.89, and if we scale them, this will result in, well, since it's near 10, we approximately get similar probabilities than the number we see on the logits applied to the exponential function. So 0.6 for the cinema, 0.24 for museum, and smaller until it's almost 0 for a test, which in this case wouldn't make much sense. So now let's see the effects of changing the temperature. So if we change it to 0.5, what you can see now is that 2 increased to 4, which increased the result in the exponential function even further. And obviously larger numbers get larger. If we again look at the function here, if you divide a number by a number which is smaller than 1, then the result will be larger than the original number. Therefore, the positive numbers get even larger, but also the negative numbers get even larger on the negative side. And therefore, as you can see here, 2 divided by the 0.5 temperature will result in 4, but minus 2 result in minus 4, which will obviously be even further down the line and approximates nearer to 0, while the positive 4 will be even larger number. And therefore, if we sum the results again, apply the normalization, you can see that the probability of a cinema increased even further, while the result of the smaller logits, like school or test, are even smaller now. So all basically 0. Now, what happens if we increase the temperature to 2, for example? Now we apply the temperature of 2, and you can see the inverse happening. You can imagine it like this. For smaller temperatures, the numbers get spread even farther on the exponential curve, and for larger temperatures, they compress near to the 0 point. So here, if we see the exact results, the exponential results, we have minus 1.5 for the lowest logit and 1 for the highest logit. So we can see that the word test has now the value of minus 1.5, which will result in 0.22 when applied to the exponential function, while before, when we were at minus 3, we were almost at 0, and now at minus 1.5, we're nearer to the 1. And again, that's how you can visualize in your mind the temperature effects. If the temperature gets larger, the exponential function results will get nearer to the 1, and if it's smaller, then it will spread apart. We can look at it if we increase the temperature to 50, for example. So you can see now that the result are really small numbers. Therefore, the result is very similar for all the inputs, and if you normalize them, you can see that the probability for the word test, which originally had 0.004, is now at almost 20% and similar to the word which had the highest probability. And therefore, if you increase the temperature to a really high number, the result becomes gibberish, because the tokens which make no sense in this context also get a very high probability and will be picked based on this probability. What happens at the end? So from all the tokens, the model is now sampling the results. So the first token will pick a probability of 21%, this token with 19%. And if you look at the temperature 0.5 again, then our token for cinema will be picked with 87%, while our word school will be picked with 0.3%. So almost no chance that this word will be picked in the result. Here I have a plot to visualize the effect. The blue bar is the fixed value of 1, and again, if we decrease it to, let's say, 0.5, we can see again that our cinema value increased and our other values, which are 1 or smaller than 1, decrease. And the inverse happens if we increase the temperature. Now you can see again that our cinema value decreased a lot, while all the other tokens increased. Now let's make a concrete example by calling Openai. So I built an LLM service here, which basically just gets the Openai key and sends a request to GPT-4o. We can define max tokens and temperature, also prompt and system prompt. And I'd say max tokens of 100. We don't need a large response here. With a temperature of 0, where can I go to for a fun time in San Francisco? So here we can see a result. San Francisco is a vibrant city with a lot of activities. And for a fun time, you can visit the Golden Gate Bridge, see the Alcatraz Island and the Fisherman's Wharf. Seems like a good response. Now let's see how the result will look if we set temperature to 2. In this case, you can already see some gibberish tokens which make no sense, not even English in this case, different languages. Here a few classic layers: friendly, amidst, dazzling, yata, ink, empty. The sentence doesn't even make any sense, so that's the result of a higher temperature. Complete gibberish. Since lower tokens again are scaled up now, and the result is sampled based on these increased probabilities now, which results in gibberish. And one thing, if you put temperature to 0, then only the highest predicted token will get 100% and the rest will be 0. That's why it's often recommended to put temperature to 0 when you work with RAG, because you want to be very aligned from the output from the vector database, and therefore only pick the highest probability token and not any other tokens. Okay, with that we are at the end of the video. What can you take away? I would keep in mind the exponential function. So if you apply a temperature smaller than 1, a larger probability will get a now even larger probability, and tokens with a smaller probability will get an even smaller probability. And the contrary happens if you use a temperature larger than 1, then the logits will obviously get smaller, and therefore if applied to the exponential function also will have a smaller result, so they will be compressed. And if you get a really large temperature, then the result will be compressed across the 0 point here, and in the end result the probabilities will even out. So that's it for this video. I hope I could explain it in an understandable way to you, and thank you for watching. Click the like button, click the subscribe button, and see you in the next video.